Hey folks, my name is Blair Coates, Communications Analyst for the Division of Engineering Services, and today we're at the American River Bridge project. For our viewers, can you start by just telling us what is the American River Bridge project and why is it so important?
Well, the project is important because the bridge, original bridge was built in 1950. So that bridge is beyond its service life and we need to replace the deck. In order to replace the deck, it included widening the bridge 54 feet to the east. And we had to build brand new foundations, scour protection, and it'll include a bike path and pedestrian overcrossing there on the south side, and sound wall and MSC walls.
Wow, with so many moving parts like you just said, I bet there's a lot of research that has to go into getting this thing right. Can you speak to some of that research for those folks at home?
Sure. A lot of what was required to get this project started was a lot of environmental studies. Make sure that we don't create too much noise for the public, surrounding public. There's a lot of neighborhoods on the south side of the project. We did a lot of studies to make sure that we didn't impact any wildlife. In particular, we had bubble curtains that were installed during the construction of the bridge inside the water. And there was a lot of other things that we did to mitigate any potential impact that the project would cause. There's a lot of challenges when you're building a new project or a new bridge and you're trying to tie into existing. So a lot of that went into the initial project development is that we had to have 3D scans of the existing bridge. We had a LiDAR, we had drones fly the bridge. A lot of survey work was done up front to make sure that when we build the new bridge that everything ties in correctly. So during the development of the new design, we ended up using Tekla, which is a 3D modeling software. So we were able to model the portions of the existing or the new bridge and the existing bridge were modeled all the way down to reinforcement, and it's a 3D live model where you could turn around, put it on the cell phone, come out, and with virtual reality you could actually just hold it and see the bridge in space.
Wow. And
it's all geo-referenced. So we did that. We used AutoCAD Civil 3D, and we're using digital forescales now. So everything is digital. We're able to share that information with the contractor, with the manufacturers, and we're all speaking the same language. So it's been really easy to check all the work, check all the manufacturing, and ensure that everything is going to work out and be constructed per plan and spec.
So Luis, you spoke to some of the challenges earlier. Can you kind of give us a little bit more detail on what those challenges look like for the American River Bridge project?
Sure, we had various challenges, but one of the most challenging aspects of building this bridge is the manufacturing of the steel girders. That is going to require a position that we're within 1/4 of an inch tolerance in construction, and that's pretty tight. The instrument itself has about that kind of variance. So what we're doing is we implemented a 3D scanning of the existing girders up in Washington. So we went up to Washington, we scanned those with a 3D scanner, and we brought those back into AutoCAD Civil 3D. And we're going to compare that as built, the anchor bolts here on site, what's been built here, and make sure that everything lines up correctly. And go back and forth with the manufacturer, with the contractor, and ourselves, and an independent survey company to make sure that the pieces all fit. So it's pretty much building a Lego set and make sure that everything fits. That's what we're doing, and we're doing that digitally. Okay, one of the challenges that we faced here was pumping concrete into the footings because of environmental restrictions. We can't have any active concrete pouring into the river. So one of the systems that we used is a Conco system, which you'll see back here, and it's a slick line system typically used to pour high-rise buildings. But what we have going on here is we have 3 different pumps actively working to get the concrete pumped into the cofferdam, which you see back there. That's a Pier 3 cofferdam. And we have another pump there that pumps it down about 15-20 feet to the bottom of the footing. And we had to modify the concrete mix to get this to flow properly, use some additives to keep it fluid, and it's been a challenge, but it's been something that we've been able to work with the contractor to use an innovative method to use all the concrete on this project.
Hello, so let me show you a little bit about what's going on here. On your left side we have a 248 crane. That's a 200-ton crane, and it's currently moving all the rebar into a materials barge. Right next to it, we have the concrete pump, and this is really cool because it goes around all the walkway and across until it hits the cofferdam that we want to pour. Right now, we're currently pouring a footing, and this runs in a slick line. While we're over here, we have cofferdams. These cofferdams are permanent. We're gonna cut, once the footing is poured, a couple months from now, we're gonna cut them and we're gonna put concrete on them.
Can you speak to some of the challenges that we have to overcome when we're working on something as the American River Bridge project?
Yeah, some of the challenges that we've encountered is getting a precise location of the bolts for the girders. We have to be as accurate as less than a quarter of an inch. And this is because the girders are prefabricated. So once they arrive on site, they have to fit straight exactly on top of the caps.
And lastly, we speak to a lot of aspiring engineers, a lot of college students. Can you just give them some sort of advice for anyone looking to get into the engineering profession?
I think just remember all your basics and just stay curious. There's always more to learn. There are guys that have been here for 20 plus years, 30 years, and they're still trying to figure out new things all the time, especially with technology changing, and just be open to using whatever is available to you. There's always more people that can also help just teach you things also.
That's sound advice. Thank you, Jeremiah. And folks, stay tuned for much more.